Hello, I'm Phil from Arizona Rock and Mineral Company. We're going to continue with our series Talking Trains. We did the first section, talked some about switch machines. There's a little bit more to mention about those. So, anyway, we used to use the old Cadillac switches, the Chemtra ones, and these were spendy, but people liked them because they had a lot of extra contacts on them to make signal lights come on and so forth. And I haven't seen these for sale for years, so forget these. But they were the best we had back then. And then of course you got Rix Racks. They sell for about $13. They're just a twin coil machine with, I think, frog contacts. And then you have the famous Tortoise ones. They're 20 bucks. But they're very popular and people like them, so they managed to sell quite a few. The other switch machine I was talking about is by Scale Shops, which I've been using for 20 years. Well, I just found out yesterday, George Stoll shut the doors. Walters, tried to get him too hard of a deal going, and he couldn't do it. They want to cut his price. Finally says, forget it. Take a long walk on a short dock. And then they come back a little later and they want to buy the name, Scale Shops. George says, how much? 200 bucks. Take another long walk on a short dock, I'm glad he did it. So George just shut the doors. Now, if you'd have told me this was going on, I could have helped him. You don't need Walters. He could still be making money, but he got rid of everything, kind of mad. So anyway, that's all over. But I have enough Scale Shops machines here for my lifetime, so I'm going to continue to use them. And I'll get into how they work. They're out there somewhere. People will be selling them on eBay or whatever estate sells. You'll find them. They're not totally gone. John Allen used to use pinball machine relays of all things, because there wasn't much stuff like that in those days, but he managed to make those things work. I don't think you're going to find pinball relays anymore. Then there was some air powered units, which meant you had to have some compressed air to make them work. And you had a little valve on your control panel to move back and forth to determine which way the switch was thrown. So instead of running wires from your switches on your control panel to the devices, you ran, I suppose, some plastic tubing. But I haven't seen those available for a long time. So like they might have been pretty good. And then we get into, we're going to get into electronics, some more electronics. I have a lot of projects I've worked on, and I'm going to get into it and tie it all together so you know what really works for me. In fact, I should write a book on my favorite electronics projects. But there's no money in that, so why bother? What I'm going to sell, a few hundred, whoopie-doo. So we'll just talk about it in this video. The very first thing that I'll bring up here is a little device called a train detector. And it's got a couple transistors, a diode, a little capacitor, and about 5 resistors. It's called a block in use detector. So if you have a train on a siding where you can't see it, well, this will let you know if something's on it or not in that section of track. You can have repeater lamps on your control panel showing that siding, or it could be a spur or it could be a passing track. There's one little disadvantage with that. If you can't see it, where do you know where the train is in? Is it all the way in or not? So one thing that you can do is you can cut a gap in the rail, like say a foot from the turnout where the train would leave. You cut a gap in the rail and the train will stop. Now, you can put a diode across that gap, and when you reverse the circuit, the train will back out. But if you don't want it to back out, you want it to go forward, you have a toggle switch that will power that dead section of track, overriding the diode cutoff circuit. So you could use these for that. And they're very inexpensive to make. And what's cool about these is they have the capacitor on it. When a train goes over some dirty track, the thing doesn't sit there and flutter. It has what you call a hysteresis principle, where there's a delay of about 2 seconds. So the lights will remain steady no matter which color is on, the red or the green. Now, I mentioned these diodes. Scale Shops, I got packs and packs of these things. I got them from Bruce real cheap, so I use these an awful lot. And this is what I've talked about using across that rail gap. Okay, grade crossing flashes. Well, the electronics book right here shows you how to make them, but they're very tedious. They actually show how to make the detector for it, which makes the lights flash alternately back and forth. I got some here from Oregon Rail. Here's the ones from Oregon Rail. They're a kit. And you know, they're kind of tedious to put together, but they do work. And of course you run them off of a filtered DC circuit is what I do. I make those up. And then to make it work, you have a flashing unit, which you could build yourself or buy one. I got this one here from the Circuitron people. Same people that make torque to switch machines. Boy, they're done very, very nice and neat. And it says even made in the USA, of all things. And you can adjust the flash rate with potentiometers on either side. And you power these with filtered DC. And it will make your flashers. I had one here, but we stepped on it one time. Lost track of it. Then, go ahead and turn that volume up, George. Somebody walked off with my... Gotta have radios to communicate. Turn the volume up a little bit more. We're gonna pretend the train is coming through, which gets us into the twin T block detectors. Okay, turn the volume up more. Okay, is it on? Does it have speed up going on it right now? I guess so, yeah. Okay, blow your diesel horn. Too long. One short, one long. Long one. Anyway, when that train enters that block, we use the MRC sound throttles, not throttle, but what they call symposium of sound, whatever. And now put the crossing flasher on. Turn the volume up more. The crossing bells. Well, the twin T will make that all come on, except we have to push a couple buttons and hold some levers, you know. Okay, that's enough of that. My radio cut out. So much for those batteries, huh? Well, anyway, let's say we have our twin T that allows the red light to come on when the train is in the block. And you can see I tag wired these in the back. 3 power transistors and a smaller power transistor. You could make what you call a photo etch board, because I got a lot of them, but I don't want to get into all those chemicals, so I just tag wire them on the back. So anyway, you got a red light protecting the block from the front and the back, and you're going to switch your cars off that block into a siding. And the train might have to go into the next block to reach the spur where they cut the train, which means you're going to leave your caboose in the block all by itself, all vulnerable. However, this caboose has what you call wheel sets that conduct some power across to make you think there's an engine on the track, which will keep the light red, keep the block light red. And I think they're made by Logitech or something like that. But anyway, I have them on one truck, 2 wheels, and it keeps the light red. So anyway, now you got a caboose all by itself, maybe some cars ahead of it on the main. Well, now you got a dark caboose. We can't have a dark caboose, so I have a toggle switch right here. Now whenever the train is in operation, the caboose lights are on. Can you see the caboose lights on? Even got the conductor there. So this just never ends how much stuff you do, okay? Just on and on and on, all these projects. And I lost my teleprompter. What did I do with my sheet? I just had it here a minute ago.
Underneath.
Probably underneath right here. Okay. Okay, we still on? Okay, there's other track detector systems out there. There's some that use photocells to trip block signals on. The only problem is they're only one direction, so you gotta hook it up for two directions, which means you use four photocells totally. And I don't know if you need two detectors or not, but and then they're hit and miss. Then you got reed switches that could be used. A little magnet underneath the pile of the engine, and it closes the reed switch, and it makes the detectors come on. And the best thing is the Twin T. Twin T does it flawlessly. Well, that concludes tonight's session. We'll be back in a few more days and get into some scenery items, how we make it, and you can see what they look like. Thank you. No? Hello, I'm Phil Anderson from Arizona Rock and Mineral Company. I'm going to do a little video here on what it takes to mount a switch machine underneath the layout. And I like to do as much prep ahead of time so all the pieces and parts are ready to go. And I'm only spending a few moments on the layout. Excuse me. What we have here is a Scale Shops motor-driven switching machine. And unfortunately, George Stahl closed the doors. Walters gave him too much a hard time trying to lower his price, and he can't do it for any less. So they just stopped ordering. Walters, I never could deal with them anyway, so good for George, he's out of it. But anyway, I have a lot of these. There's probably thousands of these out there that people haven't even used. They'll show up on eBay or wherever. You can still buy them, I'm sure. But then this is the kit, so I'm not going to get into how to make the kit. Anyway, we put this together a few years ago, ready to use for this part of the layout right here. And I want to install it underneath here. So what I do is I pre-make the linkage for it. And I decided that I would make that as far as I can go. You can see the little hook that comes down, and that goes through the tie bar on the switch. Now you could put it between the rails, there's a hole there too, but my dimensions would have it cut into one of the ties a little bit, so I elected to put it on the outside. So this here is 1/16 tubing. So I drill a hole in the layout 3/8 of an inch away from the hole in the tie bar. And that's real critical, you get that dimension as exact as possible. Now there's a little bit 4.5 movement there if you're off center. It'll still work. Then I cut some brass tubing, 1/16 brass tubing, about 1.25 inches long, because I'm working with 3/8 plywood. And then I use music wire for this part, 32 thousandths music wire. Now I destroyed some material here by putting all the bends in it ahead of time, because you won't be able to see under the layout what I do. You want this tube to fit tight, because the up and down movement needs to be zero, none of it. Okay, let's just look at the turnout machine right now. Before I put that on the layout, I want to make sure it works. And it's run by AC. Right now I have 3 volts, 2 batteries, but eventually when you run AC with all the diodes in the circuit, it turns it into DC, just like these 2 batteries would do it. So that works fine. Now what's nice about these motors is that you have a toggle switch on your control panel. And you can throw the toggle to point to the direction you want the train to go and leave it there, because the motor points shut the motor off, so there's no burnout. The toggle switch tells you all the time which way the turnout is thrown. When the turnout is thrown, I like to use these little dwarf signals just because I like lights, okay? Now this turnout will require 3 of them. Here's red and green. We'll use 2 of those with the turnouts. With the diversion route, we use a yellow, green and yellow, or red or yellow, I'm sorry. So anyway, they will work with the turnouts. They're LEDs. Now, there's another feature about these machines. They have contacts for frog. Now, this turnouts over here will swing the camera this way. Here's another turnout, and there's a little brass connector that comes out here where you connect your frog wire to power the frog, and it gets power from either stock rail, and the switch will determine that. Then when I get it underneath the layout, I use these terminal strips to organize my wiring, and my resistors will go here for the dwarf signals, the appropriate resistor. You see I have common, the track toggle switch that goes in the control panel. Here's the frog connection. Now the system requires a power supply, and in this case it's recommended to use a 12.6 volt AC power transformer, but you want one with the center tap. When you use the center tap with one of the extremity wires, you have 6.3 volts. Well, these machines work on about 3 volts, so you want to get that voltage down. And what I do is I take a piece of perf board and I wire in some diodes end to end to end to end and back the other way with them reversed, to one direction reversed the other way, because we're dealing with AC. Now what's nice about diodes is they will drop the voltage about half a volt per diode. So if you want to drop it 3 volts, you do the math. Use about 6 diodes. But remember, you're going to reverse them the other way too. Most of mine probably run close to 4 volts, because when you get them in action where there's a load on them, you might need that extra voltage, because here it's free running, just freewheeling. But when it has to do some work, it might take some more power to do that. Now what I do is I drill this hole here for the throw bar. I use a 1/16 inch drill bit to drill that hole through, and then I have the music wire and brass wire. I like to use music wire for the actual actuator here for the track. Now there's one here bent up already, so what I do is I make this bend and this bend and slide the tube up, and I force it down into the bench work. Then once it's in place, I'll make a bend right angles. That controls, there's no up and down movement once you do that. Now I make another bend down about 3/8 of an inch away, and that allows me to get it into the linkage I made. Now this will be upside down, so I'll get this started in here. And what I do is, this tube in here, it likes to get, sometimes you need to take a small drill and clean out the burrs inside the tubing so it gets started. So anyway, it would look like this underneath the layout. Then when you get that in position, you bend this over. I have some extra material here, so you just bend that over so that it can't come down anymore. Well, let's show what I did here. I like to use brass wire for this part of the linkage. And what I did is I soldered a little piece of tubing. I rolled the wire around the tubing and soldered it. That way there's no extra play, or there's no binding. And you put this little kink in it right here for adjusting the throw either way. And when you start, you want to put the turnout in the middle. You got to do it by hand. You put it right in the middle so it's equally spaced from each set of points. Then you also want to put some Campbell ties right here on the points, so keep that centered. Then when you go underneath to fasten everything, you can put this tubing up to the wire, and you put a couple little drops of contact cement. Give me that contact cement. Put a couple little dabs of one on each corner, and you hold it in position. I don't want to put too much because maybe I got to pry it off later. Because I'm not going to use a whole lot of contact cement, there's a couple holes in the base you can drill to permanently hold it in place. And you have to drill the holes through the plywood. It's really hard, because you'll never get that screw started unless you make a real teeny hole. Now the thing is permanently installed. Now you can tell I pre-wired everything, and they're going to be long enough to reach this strip right here. So then all my connections from the strip go to the control panel and power supplies and so forth. If I have more to say about it, I'll say it later.